Now that we've taken a look at some of the basics of what exponents are, including our zero exponent and our negative exponents, let's now look at how exponents work when you have them mixed together different ways. Let's look at some examples. So we're going to start here. Now, please don't let all the letters make you uncomfortable. All we're saying is, let's imagine you have a number to a power, like how about 2 to the third. And let's imagine you multiply that by that same number to another power, like let's say multiplied by 2 to the fourth. What we want to do is see if there is a way to combine those exponents to make the expression look a little simpler overall. And it turns out, yeah, there is. Let's see what we've got here. So 2 to the third just means 2 times 2 times 2. That's what 2 to the third means. 2 to the fourth just means 2 times 2 times 2 times 2. Repeated multiplication of the 2 4 times. Now, if these are all multiplied together, well, then, my goodness, all we really have is a 2 multiplied together 1, 2, 3, 4, 5, 6, 7 times. That's all there is. So here's what I want us to do. See if we can figure out a way to start with the 3 and the 4 and end up with the 7. Before we formalize it, let's take a look at an example with variables, because nothing changes when you use variables. If I have, say, an x times an x to the second, how about that? X just means I got x to the first, so there's a little imaginary exponent of 1 up there. If I've got x to the second, that just means x times x. If this is all then multiplied together, then really what I have is this x multiplied by itself 3 times. So what we're trying to see is there a way to take these original exponents and get this one? I hope by now I can convince you, yeah, there is. You simply take those exponents and add them up. 3 plus 4 gives the 7. 1 plus 2 gives the 3. So for this first property, a number to a power times that same number to a different power can be simplified as, I'm going to use my fatter marker here, can be simplified as that same number with a single exponent that is the 2 previous exponents added together. And on the very next page here, we're going to look at putting that property to use with an example or two. And it comes from here. If you ever want to refresh yourself, just remember what 2 to the third means, what 2 to the fourth means, and then that may explain a little bit to you why we add those exponents together. All right, I'm going to now shrink this down a little bit, excuse me, so that I can clear some space so we can look at this next property. All right, what if there's a division going on? So how about if we have, let's use 2 again, I like 2. What if we have 2 to the second power divided by 2 to the fifth power? Okay, let's see what we got. So 2 to the second just means 2 times 2. 2 to the fifth is just 2 times 2, 5 times altogether. And now let's reduce the fraction. So 1, 2 reduces with 1, 2. 1, 2 reduces with 1, 2. And what we're left with is, okay, there's nothing left on the top, which means really, we've got to remember there's an imaginary 1 on top. In a fraction, you really can't have nothing there. So if everything reduces away, there's that factor of 1 that remains. And down here on the bottom, what we see is 2 times 2 times 2. That's 2 to the third. And now I need you to think back to our previous lesson. When you have a fraction, when I've got 2 to the third in the bottom, what sort of thing flips things upside down? That's a negative exponent that does that. So just trust me here. 1 over 2 to the third is the same thing as 2 to the power of negative 3. And I want to leave it written this way, and we'll see why here in a moment. Let's do another example, this time with a variable. Let's use x again. What if we start with, say, x to the third over x to the, let's say, first. Let's use 3 and 1 again. What we are going to have then is x to the third is x times an x times an x. X to the first is just a single x, that's all it is. And now let's do that same reduction. This x on the bottom can reduce with one of those x's on the top. What we're left with is a 1 on the bottom, and dividing by 1 doesn't change anything. And on the top, we've got x times x, which is x to the second. Here's what we want to try and find. Is there a way to take the exponents you start with and get the exponent you end with? Can you take the exponents you start with and get the exponent you end with without having to do that middle step? It turns out that, yeah, there is, and I think some of you have already spotted it. To get a 2 from a 3 and a 1, you just do a subtraction. 3 minus 1 gives us that 2. To get a negative 3 from a 2 and a 5, you just subtract them. 2 minus 5 is what gives us that negative 3. So when you have a division of the same number to two different powers, what you do is you take the top power and you subtract the bottom power. Now this is an incredibly important sort of thing. This is a big, important relationship that I do want to make sure that you understand. Notice the very similar nature of the first two properties here. One has an addition, one has a subtraction. One starts with multiplication, one starts with division. And honestly, the way I tell them apart, doesn't a division bar kind of look like a big old minus sign? That's one way to remember it. When there's division, you use a subtraction. When it's multiplication, you use an addition. Okay, then we've got one more property I want to look at, and that's when you have a power raised to another power. So it's, notice the letter x, or whatever the number is only showing up once. This usually comes with parentheses. So let's look at two examples again. How about this time for a base? Let's use a 3. Let's imagine I have 3 to the second power, and that is then raised to the 4th power. Let's see what that means for us. That means I've really got 3 to the second times another 3 to the second times another 3 to the second times another 3 to the second. That's what this exponent of 4 tells me. I multiply this 4 times together. Let's now apply our first property that says, okay, if I've got 3 to the second times 3 to the second times 3 to the second, I can add these exponents together. So 2 plus 2 is 4, plus 2 again is 6, plus 2 again is 8. So 3 to the second, in parentheses, raised to the power of 4, ends up being equal to 3 to the power of 8. Looks pretty good. Let's do another one with variables. How about x to the 5th to the 3rd? Let's see what we got. So that means I have x to the 5th times itself again. Total of 3 times. That's what that outside exponent tells us to do. Apply our first property. 5 plus 5 is 10, plus 5 again is 15. We end up with an x to the 15th. So here's the question. How do you take these original exponents and get to these ending exponents without having to do that middle step? Once again, I know a lot of you have spotted this already. Well, to get an 8 from a 2 and a 4, you multiply them together. To get a 15 from a 3 and a 5, you multiply them together. So x to the power of a raised to the power of b is just x to the power of a times b. All right, let's use this now to simplify some expressions. Now, here's the thing. Some of these are going to look a little bit scary. That's why we're going to break it down and take it a piece at a time. So I notice here that to start with, I have a whole bunch of things that are all multiplied together, right? When you see variables written next to numbers, that means you're multiplying them. The dot in the middle here means multiply. We're going to take it now a piece at a time. The steps here say, let's deal with the coefficients This is the numbers that are in front, and each variable separately. Okay, so here I've got u's, I've got v's. We're just going to take them one at a time. Let's start with the 2 times the 5. If it's just 2 times 5, that I know you can handle. That's going to take us to a 10. Perfect. Now let's deal with the first variable, so my u's. U to the 4th times u to the 2nd. Okay, I've got u to a power times u to a power. I know that means that these powers need to get added together. 4 plus 2 should give me a u to the 6th overall. Now let's do something similar with the v's. Okay, so I got v to the negative 1 times v to the 4th. That means that for my exponent, v to a power times v to a power, I want to add the exponents together. Negative 1 plus 4 is 3. So v to the 3rd. This, my friends, is our simplified expression. You know you're finished when you don't have any other u's or v's floating around. So I've got just u's all together, just v's all together. Okay. And you want to end up with positive exponents if you can. So if you do get a negative exponent for your final answer, just move it to the bottom of a fraction, make it a positive exponent. Okay, let's see next what we have for a few more examples. All right, let's take it just in order here, left to right. Now, if you're feeling confident that you know what to do, I want you to do a quick pause, do this first one, and then unpause when you're ready to check. If you're not feeling as sure, let's talk together. Okay, what makes this one different is that I already have I've only got one coefficient, my x's are all together, my y's are all together. The only issue here is that some of the exponents are negative, and to be simplified, I prefer to work with positive numbers if I can. So let's fix that. If an exponent is negative and you want the exponent to be positive, just move it. So the 3 I'm going to leave where it is, but we're now going to make a fraction. X to the negative 4th is just x to the 4th flipped upside down. So when you move that to the bottom of a fraction, the sign of the exponent should change to a positive value. Do a similar thing now with the y. Y to the negative 2nd up top here gets flipped upside down, becomes y to the positive 2nd down below. I know I'm finished because I've got x's in one spot, y's in one spot, all my exponents are positive. We're in good shape. For this next one, same deal. If you think you know what you're doing, by all means, go ahead and do it. If you're not sure, let's take a look together. Okay, here, we've got some x's and y's that we need to put together. So let's see, 7 and 3. We're going to look just at the coefficients in front first. Those don't simplify at all. That's just 7 divided by 3, nothing to do. I'm going to set up a fraction over here, 7 over 3. Let's now let's go alphabetical. Let's deal with the x's. Now, there's 2 different ways to deal with the x's, and I'm going to show you both of them. I want you to use whichever you think is easier. The first is to use our property that says, okay, for my x's, take the top exponent minus the bottom exponent. 2 minus 4, that's x to the negative 2nd. And because for a final answer, I would like there to be a positive exponent, I'm going to take this x to the 2nd, move it to the bottom of a fraction, and make it a positive exponent. Negative exponents just reciprocate, just flip things upside down. So where this shows up in the final answer is with an x to the 2nd on the bottom. Now, I told you there was another way to get there. Here's how I think about it. I simply say, okay, I've got x's on the top and the bottom. Where do I have more? Well, okay, there's more x's down here on the bottom. How many more? Well, there 4 to 2, that means 2 more. So that's what I'm left with. X to the second on the bottom. Okay, let's go here again then. So 7/3 is done. X's we dealt with. Now let's deal with the Y's. Notice here, this Y to the 0. Y to the 0 is going to be equal to the number 1. Anything to the 0 power is going to give you a 1. Therefore, this really doesn't matter because it turns into the number 1. Multiplying by 1 doesn't change anything. We don't even need to write it. So the only Y that's left is this Y that was on the top to begin with. This one is now all finished. Now for this very last one. Here's the thing. Even the best, brightest students I've ever had make a mistake here sometimes. So be very careful. Remember that a number that doesn't have an exponent written really does have a little imaginary exponent, right? It's got that little 1 up there. That's important when you've got parentheses with a power outside of it, because we're going to apply our property that says when you have a power to a power, you multiply those exponents. And I need you to remember that for the 7, that means the exponent of 1 gets multiplied by this outside exponent of 2. 1 times 2 is 2, and 7 to the second power, 7 times 7, that's 49. Now for the x's, let's do the same thing, right? X to the negative 4 to the second means I want to multiply those exponents together. Negative 4 times 2 is negative 8, and a negative exponent just gets flipped upside down to become a positive exponent. Now, when I say flipped upside down, what I mean is, imagine this as a fraction over 1. So when you flip it, the 1 goes on top, the x to the 8th then goes on the bottom. That means that over here, we're going to have just an x to the 8th on the bottom. Now, on your practice sheet, you're going to see there are lots and lots of these, and I really do need you to do them all. Make sure you check the answers on the answer key. If something isn't matching up, check in with your table mates and then check in with your teachers. We'll get sorted out what's going on.